So today I'm going to talk about the home that will save the earth. This is a project done by Wang about saving the earth with an ecological home, which is equipped with solar panel and all the natural resources that can efficiently prevent the burn of fossil fuels and global warming. For all the natural resources in this house, we are using solar panels which will absorb the sunlight and change the heat from sunlight into energy of electricity we use normally. And then we have geothermal energy. This is very important because I believe it is one of the most efficient natural resources we can use. And last but not least, we have heat energy conservation, which is also very effective. It is a greenhouse that can produce the same temperature for a certain certain space, and this space will allow us to plant our vegetables throughout the year, no matter whether it's winter or in the summer. Solar panels simply absorbs the heat from the sunlight and store it in a special material, and then later on the special material will release the heat to electricity generators. And this is a very simple process, but we need enthalpy from chemistry to calculate the efficiency of each materials for storage, and this will greatly help us to determine which material to use. Thermal energy is one of the most effective energy, as I have said, since it obtains heat from underground and where the lava is. The lava, as we all know, contains extremely high temperature, which is essentially energy of heat. And the efficiency of this will be calculated by thermal energy from physics. Talking about enthalpy and internal energy in this home, we need to know the potential energy first. So all we need for this home is more potential energy, which will be converted into electricity and so on. And the potential energy, which is simply heat energy or internal energy, is calculated by enthalpy, which is equal to U plus PV. Latent heat materials is very important for our solar panels because latent heat materials have really high energy density. Latent heat materials simply experience a phase change in which it will release a very high amount of energy. And it is very more effective than the normal sensible materials, which do not experience a phase change and simply has temperature changes. Acetone releases 100 joule per kilogram simply from freezing, and it will be 44 degrees job without phase change for the same amount of energy. And this is the enthalpy of latent heat materials and sensible materials. Also, for example, hot salt with combustion turns into energy and gas from salt, and this process is called exothermic, in which bonds forms and heat energy is released because the products have lower energy level than the reactants. Vice versa, the process of the hot salt gaining energy from the sunlight is called endothermic. In this process, the bonds break and the energy is absorbed for the hot salt, and this energy, which will in return be released later in the exothermic. So this is our latent heat and the calculation of enthalpy. To know the efficiency of geothermal energy, we need to know the heat transfer and thermal equilibrium theories. The lava from underground solidified to rocks and releases energy into water pipe from Earth. This process can be endothermic for the water from Earth, and the water will experience absorption of energy, and this will be calculated by heat transfer from physics. And now I will show you some examples of how people are doing the calculations. As we can see here, tons of energy is created from simply 267 kilograms of lava cooling down. And this will be sufficient for a family for a whole day. And this is also very uncostly. But how do we got all these numbers? So first of all, we need to know the theory of thermal equilibrium. It is simply a theory that two objects in a closed system will tend to reach the same temperature. So water and lava here are basically in a closed system underground, and they tend to have the same temperature. The water we put in there is originally having a lower temperature than the lava, so they tend to have the same temperature. And then when the water has finally reached the same temperature of the lava, the overall the temperature is greatly increased, and thus we get heat energy from it. To calculate thermal equilibrium energy transfers, we simply need to use the equation heat transfer equals mass multiplied by specific heat multiplied by temperature changed. This applies perfectly to our geothermal energy because we can simply easily calculate the heat transfer since we have all the details. We have the mass of the lava, we have the specific heat of the lava, we also have the temperature change of the lava, and then the heat transfer is simply calculated from plugging all those numbers in. Delta H is the enthalpy change of a certain material, which I have explained before, and delta S is the entropy. Entropy is to describe the microstate of a certain material. The more disorder a thing gets, the more entropy it has. And the Gibbs free energy law is described as J equals delta H minus delta S. So that's the equation here. And as we can see, when we have this equation, we just need to get the delta H and the delta S to find whether it's spontaneous or not. For example, the lava of the geothermal energy, we had positive delta H, or negative delta H, I'm sorry, because it was releasing energy to the surrounding water and areas. Also, the bonds were forming because it was turning from liquid, which is has particles more spread apart, into closely compacted particles of solid, and thus the delta S is negative too because it became more orderly. And since we have negative before the negative delta S, we finally have J equals negative delta H plus delta S. And for this, we can know that it is indeed spontaneous, and this reaction will happen no matter what. And vice versa, when it is J equals delta H minus delta S, this reaction will not happen no matter what, unless there is a very strong outside force. Also, there's two other conditions in which J equals negative delta H minus delta S. And for this equation, this is the reaction is going to happen below a threshold temperature. And for J equals delta H plus delta S, this is going to happen above a threshold temperature. And that's it for spontaneity today. And we just need to know that for the lava reaction of our geothermal energy, it is the first one, and the first one is going to be spontaneous. Thank you very much, and there is going to be a citation link, a citation page below this, and I hope you enjoy this, and see you.